Hello, this is Daniel Treadway, and this is a quick example of how the stepper motor function will work. Right here you have the Arduino, and then this is the driver board. Remember in the diagrams, there is no driver board shown, but here it is right here if you want to see it. And this is how it will work. The stepper motor will hook up to the driver board, and then you'll have two power leads going into the driver board, and this is your signal to actually control the stepper motor. And right here you see it going clockwise and counterclockwise. This is a little faster than it would actually go, but this is just to show you what it will look like. And then there'll be one wheel on the right and one wheel on the left, and it will steer like a tank. So the left one will go counterclockwise, and then you'll get a right banking turn, or the right one will go only if you want a left bank turn, or if you want to go forward, both will go at the same time. But this would simulate a spacecraft in 2D space essentially, and the stepper motors will act as thrusters to dock with a target.
Thank you, Daniel, for that opening explanation about the stepper motors. My name is Scott Green. I'm going to go over the application of the light sensors and the ultrasonic sensor on our prototype. So what we're trying to do is create a vehicle that can be guided by light and have autonomy to stop itself in a docking manner once it has completed its maneuver and docked. Applications for this, like Daniel pointed out, was if we are doing like docking with the space vehicle while in orbit, or also being that it's guided by light if we have a air vehicle that is in a denied environment where communications are being jammed, such as microwave communication or radio communication. If there is a line of sight to the vehicle, light can be sent to sensors where it cannot be impeded if there is clear skies, and the communication can be restored that way. So in the background here, the acoustic ultrasonic sensor is running on MATLAB, as you can see, and it's about 2 to 2.2 meters to the wall is what it's seeing right now. If I put an obstacle in front of it, you'll see the number change. So that is roughly about 10, 11 centimeters. So the way we have this set up is that when it gets close to its target, the sensor will send to the logic a command to shut off the forward motion. So as you can see, we get closer and closer, it gets smaller and smaller. When we get to less than 3 centimeters, it will provide the command and it will stop taking readings. But it will also, in theory, stop the stepper motors from turning too, because that is part of the logic. So here we go. And there it goes, 2.9, and it stopped completely. Now, how this works is that the light sensors itself are going to take an average between a light source, because there's two of them, and depending on where the light is coming from, so if it's up front, that average is going to be relatively equal for both of these, and that'll give the command to move forward. Now, if the light senses that there is a discrepancy between the two, such as if it was angled and the light is still up front, one side will be in the darkness and the other side will be more lit up. And it will take the average of that, and then it'll see that there is a difference that it needs to change, and it sends to the logic command for the stepper motors to turn opposite directions in order to orient itself towards the light. And it does this in little degree increments, and every time it changes about a couple degrees, it'll take another reading, and so it'll slowly tick over. Now, as you can see, our prototype does not have any wheels on it right now because we are separated in this terrible time. But if it did, it would command the wheels to turn, and once the logic has positioned the vehicle to be centered on the light, it'll give the command to take a step forward. The loop will then process again, and it'll see if it's still on the right path and step forward. If it starts to wane off, it'll take another reading, turn, step forward, take another reading, turn, step forward, and then once it's close enough, it will stop completely. So that is the gist of our system and our vehicle working. Thank you very much.